Good Thursday afternoon, everyone. Welcome to Mathematics for Construction. This is lecture 9. We covered last class pretty much everything you need to know about quadratics in terms of algebra, right? How to factorize, we use the tabular method here. We talk about simultaneous equations. These are the linear ones, right? With two unknowns, right? We have talk about surds, how to compose complex surds and conjugate surds, how to rationalize when you have a surd in the denominator. Talk about perfect squares and what complete any square is. Some people know the quadratic formula to solve a quadratic equation. I guess you could do that if you know it, right? It's not a big deal. You should show your working though. You should know other techniques, right? This example how to solve simultaneous a linear and a quadratic, or you could have two quadratic equations as well, right? Somebody could give you two quadratic equations to solve. Completing the square gives us an understanding of the quadratic function, as well as talking about last week, right? If x is a real number, then x minus 3 all squared could never be negative. So the minimum value could be 0. Something squared is always greater than or equal to 0. So something squared plus 5 will always be greater than or equal to 5, right? This value outside here is the smallest value it could be. And the value inside is the value of x. The opposite value of this number is the value of x that makes it that minimum value. Okay, so if you're given an expression like x squared minus 6x minus 5, if you completely square and write this as x plus 3 squared minus 14, the minimum value is minus 14. It's shaped like a U, and the value x minus 3 is the minimum, is the value of x that makes the function a minimum, right? So completing the square has capabilities. Writing it in this form gives you an idea how the function, how the graph looks like, okay? Today we want to continue from here and do more sophisticated maths. So we want to get into some coordinate geometry, two-dimensional coordinate geometry, not three-dimensional. We don't want to get too sophisticated, right? The textbook we have has some good notes on these things, so I wouldn't reinvent the notes. We would just run through the chapter and see what we could take down from it, what we could remember, right? So we want to start with straight line graphs. You're familiar with the Cartesian plane, the XY plane, right? We have a y-axis, which is vertical, and a horizontal axis, which is the x-axis, right? A point is identified using two coordinates. Usually we write the x coordinate first and then comma and the y coordinate. So A, this point here, A, 3, 2, 3 is the x value and 2 is the y value. Y is vertical, x is horizontal, okay? So there's a negative axis to the left for the x-axis, there's a negative axis. To the bottom of the y-axis is the negative y-axis there, right? There's positive and negative sections. We have 4 quadrants, okay? We typically count the quadrants starting from the top right one as 1, and we count it in a anti-clockwise direction. So this is 1, 2, 3, 4, okay? The third quadrant is the one to the bottom left. The fourth quadrant is the bottom right. So points on a graph, coordinates, okay, 3, 2, as I said before, you could locate a point on the graph using the x and y coordinates. They have some definitions here for what's the abscissor and the ordinate, right? The abscissor is the horizontal distance from the y-axis, the ordinate is the vertical distance from the x-axis. This stuff not so important here, right? The idea is how does different graphs look like. So we're talking about a straight line graph. A straight line graph this is one way that it looks like. It always cuts both axes, a straight line, right? Unless in the extreme case where if it's a horizontal line, it will only cut the y-axis. If it's a vertical line, it will only cut the x-axis, right? Lines parallel to one of the axes only cut one of the axes, but generally any line cuts both axes. Straight line graph with positive gradient would look something like this, right? And usually they give you an equation y equals 3x plus 2. So you see, this is an equation here, y equals 3x plus 2. We want to get into the properties of a straight line. So there's a gradient or slope, which is a measure how steep a line is, okay? The gradient is represented as change in y over change in x. So typically, you pick 2 points and you draw a triangle and you represent the y step over the x step, okay? So you see that doing some examples here, right? Like I have 3 graphs here. A is the one on the left here. You pick 2 points, A and C, and you draw a horizontal line from C and a vertical line from C, a horizontal line from A. And that triangle, you measure how steep it is. Think of climbing a hill. The more steep a hill is, the more difficult it is to climb. So gradient is a measure how steep a line is. So this line here has a high gradient compared to this horizontal line in part C, where the horizontal line has no gradient. It's like walking flat on the floor. Then you have negative gradients, right? Where it is, it gets bigger the more left you go. Okay, that's a negative gradient. A positive gradient gets the value of y gets bigger the more right you go. And straight lines are very wonderful for representing the relationship between two quantities, right? So a straight line graph tells you how much y changes with x. Graphs are very powerful for looking at trends and how two variables work. X is called the independent variable and y is the dependent variable because y is some function of x. That's why I have this formula here, y equals 3x plus 2. It says y is a function of x. Change x and it will change y. And a straight line graph is that linear relation. It means y increases proportionally or decreases proportionally to how x increases. That's really what straight line relationships are like. Okay, so measuring gradient, if you're given data, like if you're given an actual graph measuring data, you take the line and you draw a triangle. You pick 2 points far apart, you draw a triangle and you measure the vertical distance divided by the horizontal distance. Obviously, for a horizontal line, it has 0 gradient. Vertical line has infinite gradient because you're dividing by 0. Equations, right? We saw that, you know, last lecture we did a lot of equations here, right? We had 2 linear equations when we wanted to solve, say up here. This is 2 straight lines here. Graphically, there's 2 straight lines intersecting. You want to know which coordinates they intersect. They intersect at 1 point. 2 lines either never intersect or they only intersect at 1 point, right? If you have a relationship between 2 variables, y and x, is the form y equals mx plus c, is always represents a straight line, right? Straight line, the gradient is some non-zero number, right? It tells you how steep the line is, and the c, this number c, is the y-intercept, where it cuts the y-axis. Okay, so drawing graphs kind of simple from CSEC. What we want to focus on is how you're plotting a graph here. They say plot the graph y equals 4x plus 3 in the range minus 3 to 4. So you do up a table of values. Your x values start from -3 and they go to 4. And for each value of x, you calculate the value of y, which is what is showing you here. With all these values of y here, we have coordinates. So we have -3, -9, -2, -5, -1, -1. Those are different pairs of coordinates. When we represent them on a graph, we get some situation like this here. Okay, a straight line. This is a line with positive gradient. And I mean, you could do other table of values and plot a graph. This is basic stuff here, right? Plotting graphs is not too difficult, right? But whatever do, they will ask you, what is the gradient and what is the y-intercept of a graph, of a straight line. And to do that, all you need to know is the equation. Very rarely they will give you a graph and tell you find the gradient and the y-intercept. Most of the time they give you an equation like y equals 3x plus 7, and you have to determine properties of the graph itself, how it behaves, right? So we want to say thing straight line, right? So straight line has a certain equation to it, okay? Is always of the form y equals mx plus c. So y equals mx plus c. This is the equation of a straight line, right? M is the gradient, which I measure how steep it is, and c is the y-intercept, right? That's what we gathered from here. They said the following equation represents straight lines. Without plotting graphs, find the gradient and the y-intercept. So y equals 3, right? They say y equals 3 is of the form y is equal to 0 by x plus 3. So the gradient is 0 and the y-intercept is 3. So there's a horizontal line with which is no gradient cutting the y-axis at the point 3, okay? When y is 3. So if you want to, let's see if we could probably draw a line to represent so I'll try my best to draw some kind of axis here. All right, this line here, y equals 3. If we assume the big squares is 1 unit, right? That's a horizontal line running like this here at 3. Right, this is the line y equals 3, because this these big squares here represent 1 unit. Now you could try and label it. You could say this is 1 here. Right, so if you have 1, 2, 3 here, the horizontal line passing through the y value is 3. That is what this graph is here. Let's look at this example, y equals 2x. We write it, we try to compare it with the equation of a straight line. If y equals mx plus c, 2 is clearly m and c is 0. So this is the form y equals mx plus c, where m is 2 and the c is 0. So it passes through the origin and it has a gradient of 2. So we could probably draw a line like that, right? If it passes through the origin like this here, this is a gradient of 1, right? This is a graph with gradient 1. So if I represent these numbers here, y equals 2x when x is 1, y will be equal to 2, right? So that is a different kind of thing happening there, right? They had to like tilt this more, right? So you could start with the origin and we tilt it to the point where right? So you see when x is 1, y is 2. So this is the line y equals 2x and passes through the origin, okay? Y equals 5x minus 1. The gradient is 5 and the intercept is -1. So that's a very steep line that cut in this line -1 here, right? So that could be, you know, something like it cuts the line -1, the point -1 here, and is much steeper than y equals 2x. Probably looks something like that, right? And this here, you have to change this equation around. This 2x plus 3y equals 3. So you see that did some reworking, and this is where transposing and changing the subject the formula comes in. If I have 2x plus 3y equals 3, let's see that here. So 2x plus 3y equals 3. If I have this equation here, right? 2x plus 3y equals 3. I need to change the subject of the formula and write it in the form of y equals mx plus c. So I would come and transpose the 2x, right, of 3y, negative 2x plus 3, right? And then you divide by 3. So this would mean that y is equal to a fraction. You have to divide the entire equation by 3. So minus 2x plus 3. Right? And if you write this in the form mx plus c, so you get minus 2x over 3 plus 3 over 3. And that 3 over 3 is essentially 1. So you can write it like this, negative 2 over 3x plus 1. So the gradient is minus 2 over 3. So it's sloping this way, right? Where it gets bigger, the more negative you get, right? And the y-intercept is 1. That's where it cuts the y-axis, right? It's positive 1. So we know to identify y-intercept. Without plotting the graphs, you need to know what the gradient and the y-intercept is. And they have lots of problems here that allow you to do the algebraic manipulation to find out what is the gradient and what is the y-intercept. Now they have some problems they could give you here. Look at this problem. Determine a gradient of a straight line passing through these points. So essentially what they want you to do is understand the equation of a straight line, right? So this is the one equation here. There's another equation, right? This is another equation. So if we know the gradient of the line M, and we know a point x1, y1, we could use this equation here to find the, we use this formula to find the equation of a line, right? So they say here, look, -2, 5, and 3, 4, okay? So determine a gradient of a straight line that passes through the coordinates. Let's do the second one. Passes through the coordinates -2, -3. -1, -3. Okay. So we wanna do this example here. This will be example 1. So okay, what we need to do, we had to use the formula to find gradient. Okay, so we could record how to calculate gradients, right? M equals as a fraction. So if you know 2 points, x1, y1, x2, y2. If you know 2 points, x1, y1, x2, y2, we could use this formula to find M. Okay. So we're gonna basically do that here, right? What are the points? We could look at these 2 points here, right? X1, y1 is this point. So x1 is 2 and y1 is 3, right? So normally you want to put brackets around them to make sure you don't make any mistakes with BODMAS on these things, right? So what is x1, y1? This is x1, y1 here. So I could substitute for that. The y2 is the -3, right? So I could say on top here, y2 is -3 and the y1 is -3. So -3 minus 3. Okay, there's two things happening here. I'm gonna put brackets around it and probably change the brackets like that, right? So is a ratio of two differences. And what is x2 minus y2? This is x2 here, minus 1, minus x2 minus x1, which is -2. Sorry, this is -1, 3. Right, so -1, 3. So I make a mistake there. So this is x1, y1, x2, y2. So this -3 here that's just +3, right? And what is this equal to? Three minus -3. This is 3 plus 3. And the denominator is -1. Minus by minus is a plus. Okay. This is 6 over 1, which is 6. That's the gradient here of that equation. I don't think the yeah, let me work it out here. See, the gradient is 6. After I find the gradient, we need to use one of the coordinates to plug it into this formula here, right? To find the equation. So I would say it don't matter which point you use, right? It don't really matter. M is 6. X1, Y1 is this guy here. This is X1, Y1. So Y1 is -3. So I'm gonna put -3 there. And X1 is -2. So I just put some different buckets here. Right? So this is y plus 3 is equal to 6 into x plus 2 is equal to 6x plus 12. Right? Now you just change the subject, take this 3 and throw it over on the other side. So y is equal to 6x plus 12 minus 3 is equal to 6x plus 9. Right? Probably write this last part here. And that's the equation of the line. And you have to convince yourself too that it works for the other point. Like if we substitute x minus 1 into this equation here, that's -6 plus 9, that's +3. So you get +3. So these 2 points are on the line. This is how you'd work out the equation of a line given 2 points. First thing, you find the gradient, and then you use one of the formulas for the equation of a line, any one of these two guys here, to find the equation. Right? So we could label these things, you know, we could say, we could call this L1 as L1. This could be L2, you know, this could be L3. You know, we could label our formulas and we could say what to use when, right? If you're given two coordinates and ask you for the equation of a line, you have to use either L1 or L2, but you have to use L3. In fact, I'm gonna make this the first formula. This is a more fundamental formula. This look like a L1. This look like a L2. This look like a L3. Okay. So you're not really going to be asked to plot a graph really. That's more experimental work, like if you're doing labs and so on. What this maths course really is about is not really drawing graphs, but sketching them and figuring out what the lines and the curves, what they mean. You might want to find certain things. You might want to find the length of a piece of a line, or area under a line, or area under a curve, or area between a line or curve on one of the axes, right? Your physical laws are represented by equations. And when we plot them as a graph, the area under the curve or the length of a line represents some real quantity in the real world, okay? We could find out how two lines intersect, and we actually did that already. These are two lines here, 2x plus 3y equal 5 and 3x minus 2y equal 1. These are two straight lines and they intersect at this point, 1, 1, right? So we know how to figure out if two lines intersect. You take the two equations and you solve a pair of simultaneous equations. That's what this is saying here. So I have lots of examples that show you how to calculate these things. And the practical problems involving graphs here is more basically sketching and trying to figure out what is a straight line and these things, right? Very basic, y equals mx plus c. Find a gradient and find a y-intercept. The examples here are very basic as well. We want to actually move on to probably a little more sophisticated mathematics involving lines, right? So we have some more formulas here that we could find out, right? Another one is if you have a line, how we identify a line, right? You could identify a line with an equation, but a line segment is a fixed length line, a portion of a line, right? So we could say we can represent the entire line using an equation and or a letter with a subscript. For example, so let L1 be the line let's take the example equation 2x plus 3y equal 5. Right? L could be this line here. to duplicate this. That's L1, L2. Or we could even use letters. We could say this is LA, right? And this is LB. And this could be the other line here, which is 3x minus 2y equal 1. So I could give you a question like this here. For example, let LA be this and LA be that. They give you a line in terms of the equations, right? So you can label the line using a letter and a subscript. So like LA is line A and LB is line B, that kind of thing. Or it could usually give you the equation to, but is much better to give both. And if you want to prefer one, always prefer the subscript here. This is how you can uniquely identify a line, right? So that is not so much the equation of the line, but how to represent a line, LA. So a line segment is a portion of a line with a finite length, right? So for example, let CD be the line segment of the line okay? So CD is how you represent a line segment, because a line by itself, like this equation here, is really an infinite line. A line is really infinite. Like when you see this portion here, they're just showing you a snapshot of the line here in the first quadrant. But this line, it goes to infinity in both directions. It never ends. A line never ends. The entire line is infinite. But a line segment is a portion of the line. So I could say, well, you know, CD is a portion line from x equal 2 to 5, right? And which line? LA, the infinite line is this line, 2x plus 3y equal 5, okay? So a line segment is like a finite piece of thing. So you could call this, terminology here. Right, so you have some terminology for that. Take this and move this up here. So these are my my grade formulas, L1, L2, L3. A line segment can have a midpoint because it has a finite length, right? So like if I have this line here from, like say this line here, right? This one here. Maybe the midpoint is this middle area here. The midpoint is halfway between the y and halfway between the x. So when x is 4, y is 8. So half of 8 is 4 and half of x is 2. So the point 2, this point here in the middle, is the point 2, 4. So 2, 4 is the midpoint of a line. So finding the midpoint of a line is actually not so bad, right? So let's see how we could say that. If you know 2 points x1, say we call this A. So let's choose P. This is P and this is Q. This is how we label points. We label it with a capital letter and we give the coordinates. So if you know 2 points P, Q, right? So so I'm splitting this up into pieces, right? And each time we have a discussion, we introduce a formula. So if you know 2 points PQ, the midpoint of line PQ is another point, M, and this is the coordinates of M. The X coordinate is the average of the X coordinates, so the 2 points, and the Y coordinate of the midpoint is the average of the Y coordinates of the 2 points, okay? That's our fourth formula here. So what are perpendicular lines? Right? Two lines So two lines, LA and LB, are said to be perpendicular if they intersect at 90 degrees. So I could have two lines that intersect at almost any angle. Look at this line here. This line, the 2x line, it intersecting with the horizontal line. The angle is not 90 degrees. 90 degrees is a right angle. If you notice, the x-axis and the y-axis intersect at 90 degrees. They are perpendicular to each other, right? So perpendicular lines intersect at 90 degrees. They don't have to be vertical and horizontal. They could be any angle relative to the axes, but relative to each other, they are 90 degrees intersection, okay? So we have another formula here. two lines are perpendicular if their gradients are equal to -1 when you multiply them together. Product of the gradients is -1. This is B, right? So if the gradient of LA is MA and the gradient of line B is MB, then LA and LB, the lines are perpendicular if and only if MA by MB is -1. So we went through some things here. We have equation of a formula for gradient, two equations of a line, midpoint, perpendicular lines. We could find the length of a line actually. So if we usually have the coordinates, right? So if you know 2 points P and Q, and the length of is a line segment, it's not really the line itself, right? So we say length of a line segment. So if you know 2 points P and Q, then the length of line PQ is given by and there's a formula for this, right? So we say L So line segments, we could find the length of them. And we use this formula here. The difference of the x values squared plus the difference of the y values squared, and then you square root all of that. Okay, and this really is Pythagoras' theorem under the hood, right? You could see this if we do a diagram of everything, right? So let's get rid of all of this. Just gonna get rid of this line here. If I have this line here, and I want to find the length of, say, first let me identify the points, right? So I have this point here. This is 1 point. This could be another point up here. Right, so you draw a triangle and you find out what the difference, what this length is. Pythagoras theorem, right? So like this is y2. This is like y2 up here. We could so you have 2 points, x1, y1 is down here, and x2, y2 is up here, right? So where's the where's the height of this triangle here, right? Well, that's the vertical distance here is the difference in the y coordinates, right? So this distance here is actually y2 minus y1. And this distance down here is actually x2 minus x1, right? So from Pythagoras' theorem, the sum of the squares of the two short sides is equal to the square of the hypotenuse, right? So if you want to call this L, then L squared is equal to y2 minus y1 squared plus x2 minus x1 squared, right? That's what we have here. Y2 minus y1 squared plus x2 minus x1 squared. That's really the length, right? So I would use common letter for this. I would use capital letter L, LPQ. That's the length of line segment PQ, and you use Pythagoras' theorem for that. Okay, so if I have this question here, a straight line LA, remember this is how we represent lines, right? If you don't know the equation of the line, they might call it like L subscript A or L subscript 1 or something like that, right? We usually use common letters to represent a line. So this L is common. We use capital letters to represent points. So P and Q are points that the line passed through. We want to know it cuts the x-axis at point X and it cuts the y-axis at point Y, right? What they're asking here, find the length of line XY. So I basically give you a line segment PQ. I give you a line segment PQ. And from that, you have to find the line segment XY. And then find the length of the line XY. Like, so how would you determine what point X and Y is, the coordinates of X and Y? Because you need the coordinates on X and Y to put it in this length equation here. But to find X and Y, you need to find the gradient and hence the equation of the line. So you have to use these formulas up here to find the gradient and hence the equation of the line. Because you need the equation of the line to figure out where it cut the y-axis, that is the y-intercept. But you also needed to figure out where it cuts the x-axis or the x-intercept, right? I want you to sit down and think about the equation of a line, y equals mx plus c, because this year we'll get something like this here. How would you know where it cuts the x-axis? What happens on the x-axis? How would you use this equation here to figure out where it cuts the x-axis? Once you have the equation of a line, it's easy to determine what the y-intercept is, because that is c. The x-intercept is where the line cuts the x-axis. On the x-axis, all points have a y value of 0. So if you substitute y equals 0 into the equation, the value of x is solved is the point on the x-axis that the line passes through. So that could help you find the coordinates at the point x and y. And then all you have to do is plug it into the length equation and find out what that length is. And remember last week we did SIDS, right? So you all could deal with SIDS and simplify SIDS as the case may be. So try this question here. Questions can be easily stated, but it might be difficult to find it, to figure it out, right? So try this. So let me give you a help out with this question here, right? So what we should do, we need to have a problem solving approach to this, right? I want to find the length of a line segment. To find the length of a line segment, I need the coordinates of the points, x and y, because that's what this equation takes here. We need x1, y1, x2, y2. So it means I need to find the coordinates on x and y. Now, I don't know what the coordinates on x and y are, but I know they are derived from when this line LA cuts the different axes, the x-axis and the y-axis. But I don't know where it cuts the axes. I have to find that out. All I know is I know 2 points on the line. So my idea is use these 2 points on the line to find the equation of the line. And then from the equation of the line, find out where they cut the axes. And then when they cut the axes, put it in this formula. Right? So let me try that. And I kind of hinted at that solution in the beginning. Right? So I could take this solution here and just paste it here, right? What's the points? The points is -2, 5, and 3 and 4. Okay. So you let x1, y1, and x2, y2 be, I could say P. Right? P is my x1, y1, and Q, oops. P. And here, Q. Sorry, is this. Okay, it's all right. So my mission is to find the gradient. Using the gradient, I will find the equation. Okay, so let's go. I will call this MPQ. It's always good to have subscripts, right? So this is the gradient on line segment PQ, which is the gradient of the entire line. Y2 is 4. Right? Y2 is 4. Y1 is -3, right? So 4 minus 3. X2 is this guy here, 3. So X2 is 3. And X1 is this guy here, -2, right? -2. So what I'll get 4 plus 3. And at the bottom, I'll get 3 plus 2. So this is 7/5. Right? So the gradient is 7/5. So 4 minus -3, which is 4 plus 3, and the bottom is 3 minus -2, which is 3 plus 2 is 5. So these are kind of, you know, it could have been worse, but this is kind of bad, a gradient like this, right? But no problem. In the equation, I'm going to use the 3, 4 coordinate. Did I mix up something? Is 2.5? Okay. Is this what it is? 2.5, right? So y1 is 5, not -3. Sorry about that. Okay. So it'll be 4 minus 5 and 3 minus -2, right? So 4 minus 5, this is -1. So this is a little bit better. The gradient PQ is -1/5. You can leave your answer as a fraction. You all got this? Yeah? Yeah. So now we want to substitute it into the equation formula. I'll use the 0.34, right? Because well, I mean, I kind of say x1, y1, and I don't say this is x1, y1. So let me just use that, right? So y1 is 5, and x1 is -2. So y minus 5 is equal to, the gradient is a fraction, -1, 5. But this look real terrible. So using px1, y1. Y minus y1, which is y minus 5, equals m into x minus x1 is -2. So I could probably take my time and simplify this here. Take out the brackets, and this is x plus 2. So I just try to simplify the x minus -2 is x plus 2, and the y minus 5 here. What I could do is multiply everything by 5, right? So I'll end up with 5 by that is this is a technique, right? Just multiply by the denominator to get rid of it. So what is this? 5y minus 25 is equal to minus x minus 2. Right? And I could say 5y is equal to 25 minus 2 minus x. 5y is equal to, what's 25 minus 2? 23 minus x. So the gradient we know is -1/5. You could simplify this now by dividing by 5. So y is equal to minus x/5 plus you all got this? You all got this? Yeah. So the y-intercept, which is the y value of the point y, is this 23/5, right? So I could say here now, y what's the coordinates of y? What's the coordinates of y? Is a y-intercept, so the x value is 0 and the y value is 23 and 5. So there's the coordinates of y here, because y is where it cuts the y-axis. On the y-axis, the x value is 0. What about the x-axis? Where does it cut the x-axis? The line cuts the x-axis when y is equal to 0. Okay. So this equation here so I'm going to put y is equal to 0 in this equation, right? What does this mean? This means that I could take the minus x over 5 and throw it over on the right hand side. So then positive x over 5 is 23 over 5. And this means x is 23, right? So when x is 23, y is 0. That's a big value because there'll be minus 23 over 5 plus 23 equals 0. So x is the coordinate 23 and 0. You all got this for the coordinates of x and y? Which of the y? Okay. So we know the formula here. So we could bring this down here now. So I'll take all of this out here, I'll call it xy. So the length of xy is this kind of, I'll basically substitute into this formula. Now the nice thing is the y coordinates is 0 for 1 and x coordinate is 0 for 1. So what is the difference in the x coordinates? I could call this x1, y1 and x2, y2, right? So x2 minus x1 is so this is x1, y1, that is x2, y2 here. This is 23 minus 0. The difference in the x coordinates is 23. And the difference in the y coordinates is 23 over 5. Right? I mean, you could work this out on your calculator and get a decimal, but you'll learn more if you just work it out using algebra, right? So I could multiply, this could be 23 squared over 5 squared, right? So 23 squared over 5 squared. This could be look at this step here. I multiply the 23 squared above and below by 5 squared. So the 5 squared will cancel. But now I can represent everything over 5 squared. And then I could factorize 23 squared there. So let's see what we get. We get this will be 23 squared factorize this way. So I could factorize 23 squared over 5 squared, and I wouldn't get a fraction here. I'll get 5 squared plus 1. Because if I factorize the 23 squared up here, I get 5 squared plus 1. So there's a entire stuff in brackets here. Okay. And this is So this answer here is 22 over 5 by the square root of 6, 26, sorry. This is the exact form of it here, right? So that's the length of the line. This is all the work in here, right? First you find the gradient, then you find the equation, then you find the 2 points. Then the Pythagoras theorem here, this kind of easy because we have zeros, okay? So this is 22 squared over 5 squared. I multiply this by 5 squared over 5 squared. That means I could have put everything under a common denominator. Then I factorize the 22 squared into 5 squared plus 1. 5 5s are 25 and 1, 26. So 26 here. This square root removes the squares on the 25 over on the 23 and the 5. So you get this, you get 22 over 5. Hope you all understand them gymnastics every day. Okay, so you all have access to this solution here. Let's look at example 3. More examples of these formulas here. Now, coordinate geometry is one of those topics that really tests your problem solving skills, right? Yeah, you have formulas for equations that you have to use, but how you know which ones to use and when? So look at this question here. The curve CA, we say is a curve, right? Cuts the line LB at points P and Q, where the x coordinate of P is less than the x coordinate of Q. So you have some curve, right? Is a, what is it? A sin x squared term here. So this is a quadratic. And the coefficient of x squared is positive. So you know it's a U. So it's a U shape, right? So do I have a drawing program? Where is it? Photos. Do this. Let's draw a curve. If I have a curve like this here, right? That's what's happening here. I have a quadratic. Quadratic is a U-shaped kind of thing. And I have a straight line. So if you know this line y plus 6x equals 4, if I rearrange the formula, I'll get y equals minus 6x plus 4. So that's a negative gradient. A negative gradient line means that that line is sloping like this, right? And where the curve and the lines intersect, we have two points. So, I mean, this is P. This is P over here. And this is Q, right? This basically what going on because they say the x coordinate of P is less than the x coordinate of Q. So PQ is where this curve intersects with this line, right? The curve is C1. Curve I could represent it here as CE, right? And the straight line I could represent by LE, right? So LA is a straight line, CE is a curve. They intersect at 2 points P and Q. I want to know I want you to show that the length of the line segment PQ is 2 by the square root of 111. So I'm telling you what the length of the line is. I want you to show that, okay? So it's really working I'm interested in. So this kind of like a diagram here, what happening. So you need, obviously you need the coordinates of P and Q. right? But to find the coordinates of P and Q, you have to solve a simultaneous equation to get P, the X coordinate of both P and Q. And then you have to substitute the X coordinate to get the Y coordinate. You do the linear equation for that. So once you know the X and the Y coordinates of everything, you would use this formula here to calculate the length of the line. So, I mean, it's a problem solving activity. You need to figure out where you are to get and then solve the equations to get at. Is a deceptively simple looking question. It's not very long, it's just a couple of words. But the amount of work to get this done is a good deal. And you're gonna get SIDS. You're gonna get SIDS happening at some point, which is why we did that in lecture 8. We did a lot of SIDS here. Right? Well, a good bit, not a lot. So yeah, try tackling this problem. So this example 3 is a lot of work, so you could do that for homework, right? Let's try a simpler question example 4. LA is a line passes through the points P and Q, right? LB is another line that's perpendicular to LA and passes through the midpoint M of the line segment PQ. Find equation of line LB. Right? So you might want to draw a diagram of that, right? So I could, could do a pair of axes here. Right. So where I think P would be? P is -3 and 15. So -3, 15, that's somewhere up here, right? Somewhere up there in the second quadrant. -3 is the X value and 15 is the vertical height. So somewhere up there. We're not trying to be exact, we just sketch it. What about Q? Q is 7 - 5. So that's 7 and -5. So Q is probably somewhere here, quite over here. So something like that happening, right? So then, the line is obviously a negative line, right? It's obviously a negative line, PQ. This is P. Ooh. This is Q. So that's PQ. So it's a negative gradient. So that's PQ. LB is perpendicular to LA and passes through M. M is the midpoint of PQ. So I mean, roughly where is that, right? M is probably somewhere in the middle, right? So we could think of it as there. M is somewhere in the middle. And L2 let's bring it out here, right? L2 is a line that kind of perpendicular to PQ, and it kind of passing through, right? Passing through M, the midpoint. So this is L2 here. well, LB, right? As LB. LB is a perpendicular to LE and passes through the midpoint M. So how to find our midpoint before I find that equation, LB. Find midpoint, how to use these two coordinates there. And then how I know the equation of the perpendicular line? Well, I need the gradient of the perpendicular line and a point. So I need to find M, which is the point. I need to find the gradient of LB, but the gradient of LB comes from the gradient LA, PQ. And I have to do some transposing with that, okay? So how are we gonna start this question here? Gradient of PQ. So I could steal this right down here. P is minus 3, 15, right? And Q is 7 and negative 5. So what's the gradient of PQ? Y2 minus Y1, X2 minus X1. So where's Y2? Y2 Y2 is minus 5 and Y1 is 15. X2 is 7. X1 is negative 3. Okay, so minus 5 minus 15 and 7 minus 3. So minus 5 minus 15 is what? That is minus 20. And 7 minus 3 is actually 10. So the gradient is negative 2. That's the gradient this PQ line here. Right? Okay. Now I need to find the gradient the perpendicular line. So I go up here and we could steal something. Right? So I could write this here now. So LB, LA is PQ, right? So I'm gonna say M PQ. Right? If the gradient of LA is MPQ and the gradient of LB is MB, since LA and LB are perpendicular, we must have MPQ by MB, which is the gradient the LB line. When you multiply them, you get a negative 1. So what's the gradient of MPQ? Negative 2 times MB is equal to minus 1. So therefore, MB is a half. Minus 1 over minus 2 is a half. So that's the gradient of the perpendicular line, LB, right? Now we want to find the equation of LB, right? So Let's steal all of this here. Right? We say in y minus y1 is equal to m into x minus x1. x1, y1 is, now what, before we do this, right, we need to find equation of LB, but I don't know the point that LB passes through. Where does LB pass through? LB is perpendicular and passes through the midpoint. So how to find the midpoint of PQ? So how to do that first? So where is that? Right. So before I do the equation, I have to find midpoint of PQ, right? So M is given by this expression here, right? So you add up the x coordinates, divide by 2, and you add up the y coordinates and divide by 2. So let's do that. Right? M is the point x1 is -3 and x2 is 7. Y1 is 15 and y2 is -5. So I have something like this here, right? The 2x values is -3 and 7, right? And the 2y values is 15 and -5, right? So let me simplify this now. Seven minus 3 is 4. And 15 minus 5 is 10. M is 0.25. Right? So M is 0.25. So now LB, which is perpendicular, we know the gradient of LB, which is a half, and we know the point it passes through, M, right? So I could say that line LB has a gradient of passes through the point M to 5. Okay, so we can use this to find the equation of LB. Oops. So what we'll do, we write this equation again. And what is y1? In this case is 5, right? So y minus 5, x1 is 2, and the gradient is a half. All right, so a half by that. So I could simplify this now. Oops. A half by x is x over 2, right? And a half by 2, by negative 2 is minus 1, right? And then I could simplify this. Y is equal to x over 2 minus 1 plus 5 plus 4. Right? So this equation is the perpendicular bisector of line segment PQ. That's what I wanted. LB is a line is a perpendicular bisector of PQ. It's perpendicular to PQ and it bisects the line PQ in half. That's the diagram we have here. Okay. So that was all the working for that. Now, I mean, the working is not a lot of difficult arithmetic, if you all notice. Just changing the subject of the formula, substituting into a formula. Again, this is not a hard equation to solve. These are not hard things to do. Straight line coordinate geometry, not that hard. Okay. When you have to find lengths and areas, which is the next question I'm going to give you, that's when it'll start to get interesting, right? Example 3 is a more involved question because it's a curve intersecting a line, which is something like this here. You want the length of the line, right? So you have to kind of figure out what you need to get, and they tell you what the length is. So I mean, you know what it is, but you have to get it in this form: 2 by the square root of 111. Right? So that's it there. So you have a challenge question here, example 3, where I tell you what the length of a line is, but this is a real serious question now, example 5, okay? It's given in English, first to begin with, there's a lot of words. LA cuts the y-axis at P and cuts the x-axis at Q. LB is perpendicular to LA and passes through the midpoint M of the line segment PQ. So M is the midpoint of PQ, right? Now line LB also cuts the y-axis at point R. Given that information, if I tell you that LA, the equation of LA is y plus 2x equals 6, right? Find the area and perimeter of that shape ORMQ. ORMQ, of course, obviously if it have 4 points, is some kind of quadrilateral, right? So now let's sketch a diagram and figure out what's going on there. O, of course, is the origin, right? This is a serious CSEC question. This is not even this is not advanced maths. This is a serious CSEC, a hard CSEC question from like 20 years ago. Or maybe more than that. When in the days when I used to write, when I wrote CXC 30 years ago or something. So yeah, example 5 will work out. It'll take a while. This is the kind of level you have to be on before we start to do this course, right? So today I cover coordinate geometry, basic coordinate geometry. We know how to find when a curve intersects a line. That's what example 5 is about. Not 5, example 3. And we did that somewhere up here, right? Where is it? Right, simultaneous, linear, and quadratic. So we know how to do when a curve intersects a line. We may have to completely square though, because it may not be able to factorize, right? This example 3 here. Example 4 is not a hard question because it's really just lines that have no curves. Advanced mathematics really start when you get curves, like two quadratics intersecting each other. That's the kind of things we're heading towards, right? So if you have two lines, if you have a question with only two lines, LA and LB, there's a CSEC question. This is not something that's supposed to be difficult. This is a very easy kind of question. A long though, as you see, whole day today, this whole class, I didn't do any kind of advanced arithmetic really, you know. What is this? This is addition and subtraction. This is division by 2. This is finding a square root or something, right? No kind of really complicated maths that have in coordinate geometry, right? This is surds here. This is not super complicated, right? But these things here is just division, addition, arithmetic. So yeah, have fun with that.